kind of wrap up volumes of prisms and cylinders. Example 3, it's on the page you picked up on the way in. It's actually on the back of that page. Okay. The diagram shows the dimension of a standard gold bar at Fort Knox. Nice.
What's that?
Gold has density of 19.3 grams per cubic centimeter. Find the mass of a standard gold bar to the nearest gram. All right, work with your groupies. Okay. Hey guys, there's some formulas you need to know to do this. Okay? First formula that will be helpful to you is density. So in your notebook, wherever you're keeping your notes, make sure you write it down. Density is equal to mass divided by volume. Okay, that's the first one. First thing you need to know. Second thing, as you read through here, I'm hoping something that popped out was this. Why is that such a huge deal? Yeah.
It's centimeters, not inches.
Good. They're saying 19.3 grams per cubic centimeter, and they give us measurements in inches. Does anyone have any idea, close your Chromebooks please, does anyone have any idea how many inches there are or how many centimeters there are per inch or per centimeter there? Ooh, we're close.
2.54.
Yes, 2.54 centimeters per inch. Okay? So let's write that down, that conversion there, 2.54 centimeters per inch. Now I've given you the information you need to solve that. All right, work together. Hey, convert the dimensions. Number one is convert the dimensions to centimeters. So 7 inches, how many centimeters? 17 point what? 7.8. So you multiply 7 by 2.54. Now we're into centimeters. 3.625 inches, 3.625 times 2.54 is 9 point what? 2075. Thank you. And 1.75 times 2.54. Good. 4.445. All right. Good. So we need to find the volume of this. How do we find the volume of that, Brian? All the dimensions. So area of the base times the height, which happens to be all your dimensions, length, width, and height. So the volume. KJ, what do you get for that? 0.0 what? Wowzers. All right. Cubic centimeters. Okay, how many can second that?
I got 782.
782?
0.6.
Did you round?
Rounded, it would just be 783.
No, did you? Okay. Did you round any of these?
Yeah, I just used your numbers.
Oh, all right. Good. So can we round this off to 783? Let's go to 783, okay? All right. So now if I'm finding density, density is mass divided by volume. Sam?
I got 726.
For what? Okay, did you double check these measurements with yours? Yeah? Okay, you got 727? 727?
So did I.
All right. So are these... Can we multiply these three again so we can get an accurate measure here? Make sure that it's not 783 before I change that. Jordan, you double checked it? Yeah? What do we actually get there? 9.28. 282075? Okay. Better? So does that change that to, what's that change this to? 727.7? Okay. All right. And that's a rounded amount. How many agree there? Okay. All right, now what? Yeah? Okay. Density is equal to mass divided by volume. All right. So, what is our mass? They don't actually tell us that, right? So we got M. All right, so we'll just call that M. What's our volume? 727.7. Well, we have already a variable here. Did they give us the density? Yeah, it's 19.3. So our equation, 19.3, is equal to M over 727.7. 37.7. Do I got a second there? I don't think that's quite right.
Gino, what is wrong with your mouth?
What did you do? I don't know.
Cross multiply. Multiply by both sides there. So 727.7 times 19.3 is not 37.7. Yeah. 14,000?
It's not your fault. Blame Carlo.
Okay, so to the nearest gram, right? So, 0.61, so that would be 45. Okay.
Please don't play weak like you.
Okay, what is our label there? What's this label for volume? Cubic centimeters. What's this one? This one is grams per cubic centimeter. You put your phone and your earbud on my desk. Put your phone and your earbud on my desk. Now, I want you guys to know that's the first phones I've taken away this year and earbuds because. Good job. You guys should feel special. Okay? Feel good about it. All right. 19.3 grams per what? Cubic centimeter. And this is mass over 727 or 727 cubic centimeters. I ignored the 0.7. We're just looking at labels here. Cross multiply. That to that, that to that. Huh? Tough problem, man. It's a rough life. Okay? Good, so this would go over here. This would go over here. We'd have 19.3 times 727. Yeah? Okay, and 1 times... Huh? You get it? Okay, your end result is going to be your mass is in grams. Okay? All right. That problem did not go the way I wanted it to. That took like way too long and we stumbled through it. Holy shnikes. All right. And right now I'm not sure how much of the class, how much you guys got out of it. Okay, so let's make sure. You better have this for sure. And you better have that. Important. Yes?
Why did we have to convert all the inches into centimeters? Why didn't we just turn the centimeters into inches?
You could have changed this to cubic inches, but that's much more difficult than to just change a linear. This is a cubic measurement. It's tougher to change a cubic measurement to another type of measurement when you can take a linear measurement and change it. Okay. All right. Yeah.
If you were to do it, since like we're thinking about it,
we have to like do like 2.54 squared.
You'd have to come up with a ratio. I don't want to go into that right now. That's more than I want to do. Okay? You might kind of get some of that right here with what we're doing here. Okay? So we kind of do a little of that here. All right, example 6. Cylinder A and cylinder B are similar. Find the volume of cylinder B. All right. Give it your best shot there. Okay. Example 6. What do you guys think? Yeah, Alex?
So I'm pretty sure I didn't do it right. Yeah, so I set up
Proportion?
proportion.
Okay, what was your proportion?
3 over 45 equals 6 over x.
Okay. 3 over 45 pi. Can we use that? 6 over x. Okay, so in this case you are comparing radius, which is what type of measure? Is it square, cubic, or linear? Okay, that's a linear measure. You're comparing that to volume, which is a cubic. Okay, we cannot compare it like that. Danica?
Thank you. So to find the volume of cylinder A, we need the height. So we need to solve for the height. 3 squared pi is 9 pi, and 45 divided by 9 pi is 5, which is our height. Times 2, because they're proportionate. That is gives us the height of the next one, which is 10. Cylinder B's height is 10. 6 squared pi is 36 pi times 10 is 360 pi, and that's our.
So you think the new volume is 360 pi. Okay? And that is definitely another way to go about it. It's not the way I'm going to address here. However, Danica, I want you to see if that works out. When we're done here, we'll see if Danica's method worked there. It's a very good method. Okay? We're going to compare linear to linear. What's our similarity ratio? 1 to 2, right? 3 to 6. Or you could reduce that as 1 to 2. That is a similarity ratio. That is comparing A to B, if you think of it that way. Okay? When I'm going to volume, so this is your linear measurement. Unbelievable. Okay? When I am going to volume, your cubic measurement, I've got to compare A cubed to B cubed. Okay? What is A cubed? Well, A is 1, so what's A cubed? What's B cubed? 8. 2 cubed is 8. Okay? So now I have a linear, so if I want to find linear, just like Danica was talking about, she figured out the height of this by using a similarity ratio with a linear measurement. If I want to find a cubic measurement, I have to use a cubic similarity ratio. And the way I get that is by cubing our linear measurements. So that now allows me to set up the proportion that Alex was talking about there. The volume of the smaller is 45 pi, and the volume of the bigger we're looking for, if we call that x. Cross multiply, we get 1x equals 360 pi. So Danica's method worked as well, for sure. Okay? So making sure, and we're in cubic centimeters, making sure that when you're finding the volume, you are using a cubic similarity ratio versus a linear similarity ratio. Just like if you're finding area, you have to use a square cubic or a square similarity ratio. Yeah.
Was Danica's method a lot more complicated?
You know what? Her method was what made sense to her based upon what she knew. I would say that this is the more direct route, but you know what? She problem solved on it, which is what I want all of you to do. Anytime I ask you. That's why I ask you to do things you've never done prior to me teaching them to you. That way you can make some kind of understanding for yourself, use what you already know, and then also figure out mistakes that you would have made. So like Alex said this, I'm hoping that he realizes he can't compare a linear to volume or cubic now. Okay, that's the point of us doing that. So when your teachers have you do that, they're doing it for a reason. They're not just trying to annoy you and make you take up class time. All right? Very good. Okay. I think we're done.